Microphones again.
So, hello everybody. Today, Professor Malkhaz Bakuradze gives a second lecture on the series of his lecture on Morava K-theory rings of P groups in transfer Chern characteristic classes. Yeah. So,
Thank you. Thank you. Okay. Now when the second I will speak how to do how to compute Morava K-theory on concrete example. We take this example for the moment, which integral, semi-integral, and generalized quaternion group. Here we have the definition. So we have group G is generated by two symbols A and B, and we have relations depending on two symbols E and R, and depending on these cases, on three cases, we have definition of the three groups. So in all three cases, our group is two groups, and its order is 2 over m plus 1 and m plus 2. So it contains the normal subgroup or cyclic group generated by A, which is order 2 over m plus 1. Okay, this is the definition of group. And now we need to construct some bounds, vector bounds over the classified space of this group, of these groups, and define the Chern classes, and then give the formulation of the theorem in terms of Chern classes of this bound. So here we have three bounds, the two line bounds, which are is eta 1 and eta 2. This is written representation because if take quotient G by this cyclic group, the factor group is Z2, cyclic group over 2, and as a representation, R means automotive. So it's generally represented as multiplication by -1. In the second case, we have to take quotient by subgroup generated by A, Q, and B, the partner again cyclic group, and its generator represented again is A. So C1 here, generated by A square is 0, A is 1, and A is multiplication by -1. So where two A eta 1 and eta 2 are line bonds. And if now, and we define this one plane bond over the classified space. So A and B is the G. So what is definition? So we say B and B. So AB is over G, but in some places it's convenient to A and B. This is true covering. True covering, and Z2, C2. And this means that we have involution here and free involution here. And if we take eta, okay, oh wait, okay, some bundle here, which C over B A means classifying from slightly good of one. It has canonical bundle, and now take C plus involution B over B C, and this bundle, of course, invariant under involution and can be extended or the bundle here. And notation here is the direct number. Over there, it will be some will not some playing bar, which is defined by this one, and this is called Adrian transfer. Adrian transfer bar obtained from this. So if you have two covering, take line band, its transfer band is a plane band over the base. This is definition for C sub P1. Then similarly, we can define another bundle, eta P2, eta P2 here, which is also transfer band. But in this case, we take this covering. Here before we had only A, now this one, and quotient again, cyclic group. And here we have band eta, which is the complexification of the real band, which is associated to double covering over this one, this double covering. So it has canonical line band here, real band, its complexification we call eta. So eta is over there, and it's matter over there. And we know this by this thing. So we define here two line bands and two plane bands. And we can now consider it Chern classes. Say C and X. C and X are first Chern classes, and plane bands have first and second Chern classes. Now, theorem. This is the theorem. So again, CH is the first Chern classes, and C2 is the Chern class of first plane band. Second one is not among generator because it can be expressed by generator. We will see it. So in both in all the three cases, this ring generated by three symbols, which are Chern classes. This is first Chern classes. This is second Chern class. And we have the group of relations which are between 1, 2, 3, 4. And depending on the cases, we have some cases which is even when order is 8, we have different answer. And if order is greater, it can be the results can be grouped in such way. Okay, now how to this is the second one is what the main relations they can be deduced from the relation 1, 2, 3, 4, but they are interesting. That's why I think just think that. Now, how to prove the theorem? Let us start from the proving of relation. Right? But relations come from the bundle relation. And here we define their bundle. Now look at bundle relation. So this bundle will define, satisfy the relation 1, 2, 3, 4, 5. So relations are easy to formulate and to give you an idea how to prove. Of course, first one is just what is the K-theory of classifying space of finite group. Complex representation is matrices. But you can work with matrices and so on, so similar matrices and so on, rank and so determinant and trace. But this is not convenient for us. We have the situation where the transfer plays a role. And all proofs here uses the transfer formal properties of the transfer. I will give you, for example, first one, which is we have here the following, the following, and mando, lal mando, here, theta one, the plain bundle, which is P1, here. But this is transferring theta one. Let us denote it for simplicity here. And we are using a formal property. After the main one is the Frobenius reciprocity, which means that if you take transfer A multiplied by C, where B is from any cohomology, including K-theory, from the base, and A is from cohomology from total space. That it equals, and this is a projection. In our case, it's correlating. But this works for general case. This is the same as transfer A multiplied by his RB. This is the Frobenius reciprocity. In words, transfer is not multiplicative, but it's module over base, module over homology of base. So if this means that this map is modular over the homology of P. So to prove first one, y theta one multiplied by transfer theta one, we continue this by this property. This will be transferred theta one multiplied where this goes up. But this goes, we know, this theta one plus involution theta one. So sorry, should be eta 2. Eta 2 here. Transfer eta 2. Yeah. Here. Eta both. So eta 2 here. So let us look. Let us look what is what is the involution for okay, what is eta eta P2 is transferred from C to N minus 1 to N minus 1. Transfer this one. Now apply this reciprocity and we get what? We get after multiplying C2M minus 1 by C2M minus 1 plus C2M minus 1 evolution C2M minus 1. This will be transferred one and take into account what is T in 3 cases. We always have one trivial one plus C2M minus 1 again. multiplied by involution with 2m minus 1. So transfer from 1 is 1 plus eta 1 because always transfer first one-dimensional trivial band in 1 plus theta with line band associated to covariance. And transfer with this one is covariant. This is invariant under evolution because this one will be transfer 1. This is 1 plus eta 1 multiplied it by band which covers this. Which covers this is determinant of this. Determinant goes to the sum, and the band goes playing band goes to the sum, and each determinant will go here. Determinant of our 1, 3, 2, m minus 1 transfer. So that finally we will get 1 plus eta 1 plus 1 plus eta 1 multiplied by eta 1, eta 2, which is 1 plus eta 1 plus eta 2 plus eta 1, eta 2. So the transfer P1 eta squared will get this one. This was some relation in I think second relation. The third relation, which is more looks complicated, but actually it's very easy if apply a problem use of reciprocity. Of course, we can consider matrices, but you see that we have to 2 by 2 matrices, the tensor product will be 4 by 4, and this is hard work. But using transfer, this became easier. So the first step is the proof of the boundary relation. Then the second step is to apply these relations and write them in terms of characteristic classes. But how to do this? How to do this? I will show here. So, for example, we had this last relation, or maybe some easy. Eta P1 multiplied by eta 1 is eta P1. The plane band, line band, plane band. So we can write equality of characteristics classes, yes? If they are equal, the first Chern classes are equal and second Chern class. Okay. How to compute the characteristic classes of the tensor product? This is ordinary machinery. We apply the splitting principle. What is the splitting principle? If in case here is the sum of line band, say C1 plus C2 are line band, and then eta 1 again line band. Then it is really easy because just line bands, sum of line band, here characteristic classes are computed as formal group law by its alien class. Yes. And similarly here. But But in general, our band is not the sum of two line bands. But splitting prism says that we can think as we have this case, because if consider the projectivization of our band and compute everything there, we have monomorphism. So we can do everything in projectivization space, and then again return to the old relations and think of the relations over this projectivization as relations over the base. So this is some technique which is easy, but always we need this formal group law, which is series in two variables. And in previous lecture, I studied some lemmas specific for Morava K-theory, which helps us to rewrite our band relation in Chern's classes. And again, we just record that, shortly speaking, what we exactly need, that the two properties, which is very specific to for Morava K-theory. Where is pointer? Here. I'm moving. There's two properties. Okay, now I omit the proof of these two properties and how to prove the relations now in Chern class. So first one in theorem was that first Chern classes there, 3 in this power is 0 and x 3 and x were first Chern classes of line band. Why we are 0 in this forward? It is easy because for C is first Chern class for eta 1, yeah? The line bundle over BG. And eta 1 is squared is trivial band because it's over, it's induced from the projection for BG of BG2. And over there, any line band squared is 0. And then trivial band. So to write for this formal in Chern classes, we have F, E, C, E should be electron of this is 0. But in Morava K-theory, we have C plus C, 2C, but Morava K-theory coefficient is over this field, and then it will be 0. And first, non-zero plus is Vs, C, and over 2S. Plus something which is divisible again, this Vs, Cs. So we can write this as plus something is multiplied by some element is some element I don't know h which is 0. That's why this element Vs multiplied by invertible element is 0, and that's why this Vs also inverted. That's why Vs is 0. So this is very easy relation. The others are not so easy, but in any rate, all they are obtained by applying these two properties of formal group law, by Cartan formula, and by splitting principle. So this is actually after this observation on formal group law in Morava K-theory and formal properties of the transfer. This is not so difficult. Now, for the proof other relations, we have some notations which adopted to applying these formal properties of the transfer. And here is the proof of relations. Relations first and two. Relations first will of such kind, which is very easy. Relations second is just formal group law, and likewise the relation 3, which explained here. So nothing more than, again, formal properties of the transfer and formal properties of the formal group law after this observation. Sometimes when G is order or 8, is answer is specific, because in this case where G group is 8,4, or dihedral group of order 8 or semi-dihedral 8, there's two line bonds we had, eta P1 and eta P2. They are coincide in this case. That's why relations are easier. Okay. Now, let me first omit some parts, and I will come back if I will have time. First extent, okay, suppose we prove all the relations. So what? How we know that this generators really generate all the ring, and how we know that this relation is complete system of relations. So how to check that we do have generators, and how to check the rank. Okay, this is general theory says that in our cases, when we have BH and two covering, BABG, two covering, and if that is two group, then consider cell spectral sequence. The second term is cohomology of ordinary cohomology of the two, with coefficients with Morava K-theory or BH. The second term, yes. Then tells everything for vector sequence, which is very difficult thing, but sometimes we are lucky and all the differentials are trivial and spectral sequence collapses and we can do something. In this case, so, and how, of course, it adds here, as in, by involution, yes, involution adds on BH, that's why adds on this Morava K-theory. But in our case, what is Morava K-theory? We have here cyclic group, yes? H was cyclic group. This is K generated by one symbol or two symbols, sometimes one symbol in this case, and the cyclic group U, 2 n plus U, 2 is 0. This is the Morava K-theory. And this involution acts here somehow, according to our definition of group. So as the two module, then this one, KS, VH, as a module over the two. This is direct sum of two modules, three module, plus trivial module. This three module consists of elements of the form A plus involution A. And one, invariant element. Invariant, no, this one, and invariant element are of the form. Okay. Where F here is here are the elements of this form. A plus involution A. If you want to check, the theorem says that vector sequence collapses starting from A2, and all the generators are Chen classes, that is evenly generated, no generator of odd dimension. This means that in this case, the rank of this one can be calculated in ordinary cohomology by character theory. In this case, Morava K-theory, generalized character theory, without happening on spectral sequence. So if, say, rank of F is n, and rank of this m, no, n and n, it will be 2m n. So if so, n plus m can be calculated somehow, we know this, by assumption. And if the rank itself, this 2n plus m, is also known because this is just rank of this. We know this, and rank is known. And we also know. So that checking this, actually checking of these two linear equations, so that we here should write some basis, special basis for this. We have to check that our generators in Chern classes form some special basis for this. But how? This is the easy part because this is element of such form. But we can work modulo transfer and check this. So we have to find the rank from this trivial sum. Because if we know this, we know everything, yeah? If we know M, we know N, and then check. So that the next step, if we have already Chern classes and some elements, we have to form basis for trivial summands for trivial summand for invariant elements. Okay. And this is done here. And now you see that here, of course, we have some choice for this. And this is one variant to form this basis in Chern classes, which is of correct class, what we want. Or alternatively, we can choose another basis. It depends on our wish. Okay. So again, for this particular exam, which is easy in comparing other exams, I will show this. In our case, for these groups, only Chern class is sufficient. There is no need for transferred Chern class. There's only Chern classes, so someone sufficient. This is the case. But we have the groups where they are sufficient. We have to consider not only vector bands here, but we have to consider some subgroups and complex bands there, yet Chern classes and transfer and connect them all over BG or over classified or our space group and write relations on that term. Sometimes only Chern classes are not sufficient, and let me show this. So originally, I have to say this has long history. Even this group, Tezuka and Yagita. I know personally Yagita. He proved that for these groups, the Morava K-theory is generated by Chern classes. No relation, he did, but generated such Chern classes. This also was not easy. Some time ago. Okay, now let me show example where the situation is a little bit complicated in comparison. Yeah. Now consider more general case. Here we had extension of cyclic loop by C2. Now I add some concrete evolution. Now consider any extension of the product of cyclic loop by two groups. Any. But how many? So actually there are 70, up to isomorphism, 17 cases. And theorem says that all extensions are good. Are good means that they have Morava K-theory generated by Chern classes and transferred from their subgroups Chern classes. Hmm? Yeah. So we have 17, some of there are definitions of this group. You know, yes, because it's very strange, but when you use computer and you know already the answer, it helps. But when you don't know how to answer it, it doesn't help much. I don't know why. In my case. But yes, I then checked everything by computer. I was happy that I was right here. You know. Because
that every classification problem has a quite a good item. There are very high chance that there's some mistake.
yeah. You know, but you have opportunity to check, man. It's also very helps. Okay. But before I don't know. I will show you why it's maybe if you want to apply a computer, and you are a good programmer, okay, but me not. But I'm better topologist than programmer, yeah?
Yeah.
That's why. So again, if you want to take fix some basis, you have to take special basis because you have many choice. If because if you are directly, there is very difficult to get no optimism directly. This is very hard for computer as well. Computer does not work if you just say that I have this. Yeah, singular, for example. Computer algebra singular, yes?
Yes.
If you use just usually I have this algebra and please fix me the global bug. Our thing. But if you have some can help somehow and give some hints and so this improves the work of computer. So you can check your idea. You do something and check and do it some symbiose of handwritten and program some into work. For example, very now I will show it. You will have some idea. It's not about this.
Yeah. Yes. It is finished in exactly at the half past 2. Yeah. So he doesn't have so many times last time because today.
Yeah, I confused it. I said that generalized character theory gives. Suppose you say that, okay, let's spectral sequence collapses, and rank should be something which can be calculated by generalized character theory. And in our case, okay. So the answer is as follows. This is computed by hand without appending on spectral sequence. Correct? No, no. And now this is for trivial module. No. Here, you see, what is the first one? G3. So we have these three in case we have, but in here, as we have extension of product of two cycles, we have this one. P star, two generators, 2 and V, and on 2 M plus 2 is 0 and V. And some involution for acts on this algebra, yes? But some involution, depending on. So how to decompose this? So how to decompose this? So invariant element of this. V is a free and trivial sum. We have to write here some basis and then found invariant, yes? But if you want to found the basis in terms of U and V, this is very difficult for computer as well. That's why I check, you see, this is special. So X2, so X1 here is U plus U, involution U, Q. X2 is V plus involution V. And X and what? Y here. Y2 is X Y2 is just product here. We multiply CU and Y1. And Y2 is V multiplied CV. Yeah? Here we have but this is special notation. And in terms of notation and U and V, it is stated the basis income. This one, you say this multiplied by U, this multiplied by V, this one multiplied by UV. And this is the basis. Of course, it's some restrictions to G and L, and we have to fix the rank. And now we have to just check if the things are linearly independent. But this is after some collaboration with computer. You suggest this, and then computer works with it. But without this notation, computer does not work. So you have to teach or computer teaches you something happens here. So that in general, I can just finish my conjecture is that any extension of any abelian group, finite abelian group, is good. I feel so. Because finite group is product of cyclic groups. I checked some before. So you have to check just right. The first approach is to write special basis in the special basis and check if rank is okay. The conjecture is as follows: any extension of finite abelian group by Z group should be good. That is, its Morava K-theory should be generated by Euler classes or Chen classes and transfer Chen classes.
So, thank you for the lecture, long and containing many exciting written. But yeah, so what is the importance? I mean, what is a consequence of your conjecture? So it's the correct sense. What is the relation? It as a problem or as a conjecture in mathematics? What could be good thing for that?
Morava K-theory is one of the complex oriented homology theory. Yes? That's why what is complex oriented? It means it can be obtained from the universal example complex subordinate. So that it means that if you have formal group law or any commutative ring, you can obtain your formal group from universal one. There is map from the complex subordinate to your ring. Yes, so that it's called after multiplication by rational numbers. It's called Chen. So I wanted, but Morava K-theory is better computable as Morava K as cohomology theory, even better than ordinary cohomology in some cases, which shows what, for example, cyclic groups. It's easy to compute Morava K-theory for cyclic groups when ordinary cohomology for P is odd, for example. The same for other finite groups. If you look at ordinary cohomologies, it's not easy. Morava K-theory is not also easy, but easier. Yeah, better. So after these observations, I started this similar things with formal group law for other homology theories. And looking on formal group laws, for example, this is all the 3 or 4 years old or even older result. Very new result is that I observed that if put some restrictions to your formal group law, you get some very known genera from physics, which is related to whichever goes Russian mathematicians and even some string theory and so on. And you get your ring is cohomology, and you get formal group and classes and so on. So relation is that if you look at genera, so this is one of the examples here. So,
Okay. So it means some more lesson.
Here Since now here is automorphism, the representation. This is that notation. That notation. Not that notation. Because this is not C, but some related with C and how. Yes, some relations are not usually here. But I avoid to introduce new notation because of Novikov doesn't like it. But if you have manager and what to do, yeah. I never put Georgian letters. It's completely different than European. We have original, you know that.
Yeah. Yeah, but notation
now-
is very important, yeah. Right. So Swata. Oh, yeah. Swata. Asvatya.
Not only finite groups can become installed.
So if there is no more question, let us take it.